it. I'll see if you have any questions, and we'll think about these checkpoint questions and then talk a little bit more about objective 2. Okay. While we kind of think about what questions we may have, I also got a question over the weekend, really good question about the sweat glands. So I talked a little bit about sweat glands last class, and there may have been a misunderstanding, but the question was whether or not sweat glands are an effector organ. They definitely, absolutely are. They are slightly different, and there's a huge exception to the rule when we talk about the postganglionic fibers to sweat glands. So there's a bit of an exception that you kind of want to look out for. We'll talk about it hopefully at the end of today, but sweat glands are an effector gland, an effector organ. And what I mean by effector organ is that they're going to receive dual innervation from sympathetic and parasympathetic, but there's a small exception to the neurotransmitter and the postganglionic fiber and how it behaves differently in the sympathetic system. Okay, just to make that clarification. All right, let's think about these two questions here. So the first question, which autonomic division regulates the release of epinephrine from the adrenal medulla? And this should be pretty straightforward. So which of these two divisions is involved in any way with the adrenal medulla gland? Any thoughts, any ideas? It's super quiet. Okay, excellent. So I'm seeing a lot of responses in the chat, and it's the sympathetic nervous system or the sympathetic division here, and that's absolutely correct. So the parasympathetic system has absolutely nothing to do with the adrenal medulla, ever, 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 okay? Neither does it ever have anything to do with the sympathetic chain or any type of chain. There's no chain in the parasympathetic system. There's no involvement of the adrenal medulla gland, okay? Or the adrenal gland, the adrenal medulla. Excellent. Question 2, which part of the autonomic nervous system, sympathetic or parasympathetic, produces the more diffuse response and why? So something else we kind of touched on earlier today. So which of these gives a more diffuse response? And when we think about the word diffuse, we think about kind of just going everywhere really quickly. Excellent, thank you. So also the sympathetic nervous system. Can anyone think about why, just to Can anyone think about why that would be? Just carrying on our discussion from this morning and the intention behind the anatomy. So excellent. So I'm seeing fight or flight response, which is correct. So we think about the sympathetic system as being involved with that fight, flight, freeze response, which needs to be a diffuse response. In terms of the anatomy, it's more diffuse because we've got one, the adrenal medulla involved and sending the neurotransmitters out as hormones via the blood, which is going to give us a more diffuse response. And then the second part of why it's more diffuse is because of the ganglia that are associated closer to the spinal cord. And so we have many synapses leaving those ganglia and just kind of branching out exponentially, giving us many more opportunities to send those signals out to these effector organs. Okay. Excellent. All right, let's keep going here. Let's move on. Actually, I've got a few checkpoint questions, so let's actually look at these questions. Yeah, I don't want to let these pile up. So let's look at these as we go along. So let's look at the first question here. And I'm going to launch a poll and give you a minute to poll in. All right, final 10 seconds. All right. Okay, a lot of response for A. Let's see, where do the nerves from the parasympathetic nervous system originate? A, brainstem and sacrospinal cord, absolutely correct, okay? So that is correct, brainstem and sacral spinal cord. Yeah, I don't think there's much of an explanation here. This is just a matter of fact. And so we can also think about C as being the sympathetic division. So if this question asks about sympathetic, C would have been the answer. Okay, the other options are incorrect. I do want to point out here though, so here we see, so this could have been spinal nerve. So again, that confusion between the sacral division of the spinal cord and the spinal nerves of that segment, we want to make that distinction here. So if this would have said spinal nerves or brainstem and spinal division, this would have been incorrect, right? It's going to be the sacral division of the spinal cord and not those somatic nerves. Okay, let's look at another question. I'm going to launch a poll. Okay. All right, final 10 seconds. Okay. So what is the path of a parasympathetic signal from its point of origin? A lot of response for D and B, more so for D. Let's see, D said to the parasympathetic chain. Guys, right away, that is wrong, okay? There's no such thing, okay? There is no parasympathetic chain. I really wanna drive that home. So immediately looking at that response, you should not have even entertained that option. Let's read the rest of it. Then to the ganglia located near the effector organ, then to the organ. So the rest of it is right, but the first part of it is not right. Okay, there is no parasympathetic chain or any synonymous structure in the parasympathetic division. Option B, which had the second highest response, was to the ganglia located near the effector organs, then to the organs themselves. So that is absolutely correct. So the parasympathetic system, fibers arise, brainstem or sacrospinal cord, they go all the way out as a nerve to the, now again, I want to point out another distinction here. They do not enter the spinal nerve, okay? The sympathetic fibers, we drew them out. We talked about how they enter the spinal nerve, went to the ganglia, re-emerged into the spinal nerve. That doesn't happen in the parasympathetic system, okay? The fibers leave the sacral and brainstem region, travel all the way out to a ganglia that's near the effector organ. So an example I talked about earlier was the otic ganglia, which is really close to the salivary glands. And so the facial nerve, it begins as a nerve, as the facial nerve, it travels all the way out, right? It synapses onto the otic ganglia, which is really close in proximity to the salivary glands. And then there's that shorter fiber that goes to the salivary glands. So no mention of any chain, no mention of any spinal nerve, no mention of any myelinated versus unmyelinated myelination of the fiber, okay? It's always a myelinated nerve and it synapses onto a ganglia and then goes on to its effector organ. Okay, So I'm really glad I brought this question up so that we can clarify that understanding. Let's keep going here.